2.7, which is titled One-to-One Functions and Their Inverses. And by the end of today, we're going to be able to write the inverse of a function, whether it's a linear, quadratic, rational, or square root. And then we're also going to be able to explain the meaning of inverses in real-world problems. So just want you to take a few seconds and then read through the how to find an inverse. Okay, and we're going to run through the steps together. Okay, so CJ, what's our first step?
Switch f of x to y.
Good, and then Nolan after that?
Switch the variables.
Good, so you're going to switch the variables x and y, and then Summer?
Solve.
For what? Yeah, you're going to solve for y, and then what's the last thing we do, Corbin?
Replace y with inverse of f of -1x.
Yeah, so this is going to be your inverse notation. This is pronounced f inverse, but it is the f with the -1 superscript, and then it is still of x. So for number one, we are going to do our steps, and then I'll show you in the next one how you can just really bypass step one. So step one is y equals 6x minus 8. A lot of times we'll just skip that and go straight to 2, where you're going to switch your x and your y. Okay, and then we're going to solve the equation for y. Right, so Robert, if I wanted to solve that for y, what would I do?
You're going to have to take since it's a -8, you have to add 8 to both sides.
Good. So I'm going to add a to both sides. And then I would divide 6 as my last step. Now, this is going to be a linear function. Whenever it's linear, we're going to write that in slope-intercept form. Okay, so we think of it as x over 6 plus 8 over 6. But if we're writing that in slope-intercept form, x over 6, John, do you know how I can rewrite that?
1/6x.
Yeah, so I'd have 1/6x, and then 8 over 6, we're just going to reduce, so I'm going to divide both of those by what? 2, so then I'd have what? 4/3. Okay, and then I'm going to make sure for step 4, I put that in the proper notation. Okay, so your notation is going to be important. Okay, so A was just a good warm-up. This is something that you've already done before. We are going to expand. So f of x is going to be equal to x to the 7th minus 7 divided by 6. And then I'm going to give you time to work on B and C. And for C, you're going to have f of x equals the square root of x minus 6. Okay, and like I said, for part A, you can go ahead and just start with x equals y to the 7th minus 7 over 6. Okay, and then continue from there. Okay, so let's check to see how we did on B. Katie, what did you do once you got here?
I multiplied 6 on both sides.
Okay, good. So to get y by itself, you want to move over the 6. So you'll have 6x equals y to the 7th minus 7. Okay, then you're going to add 7 to both sides. Okay, and then, Michael, how do I undo the 7th power?
Take the 7th.
Yep, so I'm going to take the 7th root of both sides. Okay, and then I'm just going to go ahead and write this in my inverse notation. So the inverse is going to be the 7th root of 6x plus 7. Okay, great. All right, now for this one, again, your first step is to switch your x and your y. And then, Emma, what did you do first for this one?
I squared both sides.
Good. So when you square both sides, that undoes what? The square root. Okay, so then I'll have y minus 6 equals x squared. To get y by itself, I'm just going to add 6 to both sides. So then my inverse is going to be x squared plus 6. Okay, scale of 1 to 5, how confident do we feel on problems like ABC? All right, let's look at D. So for D, you have f of x equals 4x minus 2 over 3x plus 1. Okay, so right away we should notice some differences with this than with the others. What's different about this one? Yeah, you have two variables, right? This is a rational function. So if you have two x's, does that mean you replace it with two y's? Yes, you do. Okay, so this is going to be x is equal to 4y minus 2 over 3y plus 1. Okay, do you guys have any intuition about what your next step is going to be? What? You are going to multiply by the denominator. Okay, so the reason why you want to multiply by the denominator is so on this side they will cancel. If you multiply by the reciprocal on the other side, you would still have a fraction. So this is just going to get rid of the fraction for us. Okay, so this divided by itself is 1, so I'm left with 4y minus 2. On this side, I am going to distribute the x. So 3y times x, I'm going to write as 3xy. I just always put these alphabetically. 1 times x is going to be x. And then to the side, I'm just going to write down what we did. Okay, so when we have a rational function, you want to multiply by the denominator. And again, that's because that will get rid of the fraction that you have. What about the next step? Do you guys have any thoughts on that? Okay, why?
Because you want to solve for
So, oh, you're thinking like, oh, that you add 2 to both sides?
yeah.
Okay, and then you'd have y by itself, but then wouldn't you also have y over here? Yep, so you'd have that y by itself. Basically, we have to find a way to make 2 y's into 1. Yeah.
Can you factor by putting 2 on the other side and then dividing by 4?
Eventually, we are going to factor. So, and the reason why we're going to do that, or what we have to do before we factor, is we have to get all of our y terms on one side. Okay, so we are going to get y terms on one side. And I always get them on the left side, because when you have your f of x is going to be on the left. You don't have to put them on the left side. Your answers will just look slightly different, but as long as they're equivalent, that is perfectly fine. Okay, so if I move all my y's to the left, that means I'm subtracting 4y. In addition to getting all my y's on the left, I have to move everything else to the right. Because if I'm going to factor, I can only have terms that have y in them. So this is going to be 3xy minus 4y equals negative x minus 2. Okay, so now I can factor out the y. Okay, so then when I factor out the y, I have 3x minus 4. So y times 3x minus 4 equals negative x minus 2. And then, Kelly, what's my last step going to be?
Take the 3x minus 4 and subtract to this side.
Yep, and then how do I do it? How do I move that to the other side?
Division.
Yep. So you're going to divide both sides by 3x minus 4. Okay, and then I'm just going to write this as my inverse now. My inverse is going to be equal to negative x minus 2 over 3x minus 4. Okay, so then I'm going to have you do e. E is another rational function. So I'm going to have you do that. And then when you're done, you can check that with your group to make sure you guys all got the same thing. Okay, so check in with your group members. Make sure you guys all got the same thing. Okay, now remember I said that I always move the y terms to the left side, so I'd have xy minus 3y equals 2x. So then I factor out my y, x minus 3 equals 2x. So my inverse would be 2x divided by x minus 3. Okay, however, I also told you guys that you don't have to move it to the left side. So if you moved it to the other side, that's okay. So if you got here and you said, I'm going to leave the negative 2x on this side, but I'm going to do 3y minus xy, that's perfectly fine. You're still going to factor out your y. Okay, and then you would divide both sides by 3 minus x. Okay, and then So I'm perfectly fine with you having the inverse negative 2x over 3 minus x. Okay, that would be an acceptable equivalent answer. And then I'm just going to show you how they're equivalent. So if you factored a negative out of the bottom, you'd have negative 3 plus x, okay, which is the same thing as negative x minus 3, and then a negative divided by a negative be 2x over x minus 3, which is what I had. Okay, so they're equivalent. Either one you have is fine. All right, now we're going to go to the back. So on the back side, we are going to work with our explanations. So this is really important. This tends to be an area on the test where you can easily get confused. So I'm going to be writing out little notes as I go along to kind of help you with those and hopefully prevent you from making some of those mistakes. So for example 2, it says the amount of a commodity that's sold is called the demand for the commodity. Do you guys know what a commodity is? Can you tell us? Yeah, it's a good, so something that can be bought and sold. Okay? So that's called the demand for the commodity. The demand D for a certain commodity is a function of the price given by D of P equals negative 3P plus 150. Now, you can see when looking at these, it's going to ask you, what does this represent? What does it represent? Write in a complete sentence. We're really going to focus on identifying the input and the output and what those mean. Yep.
Because it's demand, would the inverse be the supply then?
No. The inverse is going to be the function.
Okay, but for what it represents, does it represent the supply of the item?
No, it'll just be what the demand is. Okay, so one thing we want to focus on here is it tells you the demand D is a function of the price, which is what we have set up. We have D of P. I want to make sure that we understand a few things about the equation before we get started. Okay, so when you look at an equation, you can automatically identify what the output and what the input is. When they say that it's a function of something, okay, whatever the function is going to be your input. So in this case, our P is going to represent the price, and the price is always given in dollars. Okay, your demand is going to be given in units of whatever your commodity is. Right? So whenever I think of like a hot commodity, I think of Tickle Me Elmos because they were really popular one Christmas, and because the demand was so high, the price was going up. We could think about that for this, but then you'll see the price may get a little bit ridiculous as we get down to some of our explanations. But actually for the first one, it's kind of spot on. So for this, when they tell you a demand is a function of the price, you can identify your input and your output. Okay, so the input for this equation is the price. The output is the demand. Now, the reason why we're talking about your input and your output, when we were talking about inverses earlier, we talked about how the x and the y switch. Okay, x is your input, y is your output. So when we are finding an inverse function, the input and the output are going to switch. However, because this is a real world problem, we do not physically switch those variables. Each variable is tied to a certain quantity okay, to a certain definition. And it would be really confusing if we switch them, because then the P would actually represent D and vice versa, and it just gets a little messy. So, when you are finding the inverse for a real life problem, okay, so a situation that you're modeling, do not switch your variables. Okay, so we are not going to switch the P and the D. Okay, so do not switch your variables. You need to solve for the current input value. Okay, so instead of switching, what we're going to do is we're just going to solve for whatever our input is. So for this equation, your D of P equals negative 3P plus 150. Maddie, what are we going to solve for? The P. Okay, so we're going to solve this for P. And if you have where this is written as a function, you guys can just go ahead and write it as D. So D equals negative 3P plus 150. So if I'm going to get P by itself, I'm going to subtract 150 from both sides. Then I'm going to divide by negative 3. Again, this is going to be a linear function, so I am going to do D divided by negative 3 minus 150 divided by negative 3. So D over negative 3 is negative 1/3 D. 150 divided by 3, what's 15 divided by 3? 5, so this will just be 50. Okay, and then the negative divided by the negative will be the positive. So this equation represents D inverse. Okay, this is the inverse of D. Okay, so now you can see D is going to be your input, P is going to be your output. You're going to plug in the demand, you get out the price. So we're going to explain what this represents. So your D inverse represents, okay, and it's important that you do explain both the input and the output. So this represents the price P that is associated with, or you could say is a function of, the demand D okay, where the price is a function of demand. Okay, so the inverse represents the price P that is associated with the demand D, where the price is a function of demand. Okay, now for part B, it says to find the D inverse value of 30. Okay, so 30 is going to be your input. That means that's what you're going to plug in for what variable? Yes. Okay, so what this is saying is that D is equal to 30. Okay, so your inverse is P P equals negative 1/3 D plus 50. So I'm just going to substitute in 30 and solve. So 30 times negative 1/3 would be negative 10. So I would get 40. Okay, so you can say that P is equal to 40, or the D inverse of 30 is equal to 40. Alright, so again, I'm going to explain what my answer represents. I'm going to write that in a complete sentence. Again, I just want to stress to you that when you are explaining what that represents, you need to make sure you include the input and the output. Okay, so you're explaining both of those. Okay, so what we plugged in was 30. Because we plugged that in for D, that represents the demand. So when the demand is 30 units, 30 Elmos, the price per unit is $40. So notice when I do my explanation, I'm going to start to add in what these numbers represent. Okay, so it's not just 40, it's $40. It's not just 30, it's the 30 units. Okay, and you could even say the 30 units of the commodity. Another thing I want to make sure that we have a note about is that the inverse is going to switch your input and your output. So this is just a note. When you find the inverse, the input and the output switch. Okay, and again, the reason why we're doing this is because this is an area where students have had trouble in the past when they get to their test about explaining, so I just want to make sure this is very clear. So for this problem, we only had to find what happened in the inverse. There are some where you may have to find what happens in the original and not just in the inverse. So when you do that, just keep in mind for our first equation, which was D of P, your input was the price, your output was the demand, and now that we have the inverse, your input becomes the demand and your output becomes the price. Right? Now when you're doing this for your homework, it's not like I expect you to write this out every time, but it is something I expect you to think about before you start writing what they mean. Okay? Because sometimes when I ask people to explain, they'll flip these around. They'll say, oh, when the demand is 40 units, it'll be $30. So make sure that you're understanding where your input and your output are coming from. For part C, we're considering a new narrative. Okay, you still have the demand D for a certain commodity, but they tell you that D is measured in hundreds. But we have the same equation that we do in the first one. Okay, so it says explain what your answer in part B represents. So the first thing I want you to understand is even though your value of D is now measured in hundreds, your answer for part B is not going to change. Okay, you would still plug in 30, you'd still get out 40. let's write that first. Okay, so note, even though what it's measured in changes, okay, for this situation, okay, our solution is still that the inverse of 30 is going to be equal to 40. Okay, the input and output of your calculation is going to stay the same. Okay, so your input and your output of your calculation stays the same. All right, so if D is now measured in hundreds, Corbin, what are you thinking for this?
If it's same ratio, so like then the output measured in hundreds as well.
Okay, so what's our, you said our output?
I said like the same ratio.
Okay, so then how are we going to explain what our answer represents now? So if the D inverse of 30 is 40, how would I write that like I did in part B?
Since the input is measured in hundreds, then our output would be measured in hundreds as well, so it'd be 400.
Okay, so the ratio is actually different. So if D is measured in hundreds, it doesn't mean that the price is measured in hundreds. Okay, so it just means that this equation is going to represent something else. So if your D value is measured in hundreds, remember your inverse value, your input is now your demand. Okay, so our input is 30. So if that's measured in hundreds, really it's not 30. What is it?
It's 30 units of 100.
So yeah, and right. Okay, and we wouldn't say 30 hundred units, right? What would we say? 3,000. So what you're going to do, if D is measured in hundreds, okay, you're going to take that value and you're going to multiply it by 100, and you're going to tell me that it's 3,000. Okay, so you're not going to say 3,000. I do want to be clear on that too. So then what we would say, we can word this almost the same when the demand is 3,000 units. The price per unit is 40. All right, now for part D, there's a couple things that stay the same. Guys, stay with me. So now your demand D is measured in hundreds, so that is the same as in part C, while the price is measured in thousands. Okay, so they'll tell you explicitly what it's being measured in. If they don't say it's being measured in hundreds or thousands, it's just going to be in ones. Okay, so again, we're not going to write the note again, but it's the same, right? Okay, so we still have the D inverse of 30 is equal to 40. That does not change. The reason why I'm stressing this is because sometimes people go back and they plug in something different. So if you're finding the D inverse of 30, even if it's measured in hundreds, you're not going to go back in and plug in 3,000, because that would make 3,000 times 100. That's what you would be representing, okay? So your input and your output are still going to be the same. So your D value, we'll just write out what that's going to be. It's still going to be 3,000, so you're going to take your input, you're going to multiply that by 100, and now we're going to take our output, which is 40, And now we know that's measured in thousands. So what do we have to do with the 40? Times it by 1,000. If it's measured in thousands. Okay, so then that becomes 40,000. So then do you guys think that you could write a statement for me about the demand and the price? Got it? Nora, you want to tell me what you wrote?
I'm doing it now.
Oh, yeah. Sorry, I thought you already did it.
When demand is 3,000 units, the
Mhm.
price per unit is 40,000.
Beautiful. When the demand is 3,000 units, the price per unit is 40,000. So that would be a lot for an Elmo.
That's 3,000 Elmos.
No, but it's per unit.
Never mind.
Yeah. So if there were only 3,000 of them made, people would pay 40 grand.
Is that how much your Elmo was?
No, but they did make Tickle Me Elmos again, so then I got one for my nephew. And he just tried to eat its eyeballs, but now he'll laugh with it. Okay, there you are. Okay, and then again, just as a reminder,